My name is Michelin Wilson and I will be delivering Lecture 5. Lecture 5 will be about labor and production. At the end of last week's lecture, we saw that since the Industrial Revolution, real wages have increased with labor productivity. But how has work hours changed over time? If we look at this graph, we will see that for the average worker in the US over the 20th century, hourly earnings have increased sixfold. Work hours have only fell by 1/3, and this translates to annual earnings increasing by fourfold. At the same time, since 1950, France and the Netherlands have reduced work hours more than the United States. So how do work hours vary across countries? Workers in richer countries like the United States tend to have more free time. But free time varies across countries with similar GDP. If we compare a country like the United States to a country like Japan or Italy, or if we compare two countries like South Korea and Spain, we will see that work hours vary even though these countries have similar GDP. And GDP vary across countries with similar free time. Take a look at a country like Turkey and the United States. A constraint choice model can help us to understand how individuals make decisions under scarcity. Labor and production. In Unit 2, we saw that labor can be thought of as an input in the production of goods and services. Labor is work. We also cannot measure the effort required by different activities in a comparable way because work takes many forms. Work effort is difficult to measure, but work hours are easy to measure. As a student, you make a choice every day how many hours to spend studying. There are many factors influencing your choice: how much you enjoy your work, how difficult you find it. Perhaps part of the motivation to devote time to studying comes from your belief that the more time you spend studying, the higher the grade you will be able to obtain. That is, students who study more earn higher grades. This is the assumption on which we will base our constrained choice model. Alexi's production function translates the number of hours per day spent studying, his input of labor, into a percentage grade, his output. Studying for 4 hours translates into 50 percentage points for Alexi, while studying for 10 hours translates into 81 percentage points. If Alexi increases his studying to 15 hours, he's able to achieve 90 percentage points. Alexi's average product also diminishes, just like we saw last week. Alexi's average product of 4 hours is 50 divided by 4, which is 12.5. That means, on average, if Alexi studies for 4 hours, the average amount of points he will be able to get for 1 hour is 12.5. If Alexi increases his studying to 10 hours, he will be able to get a grade of 81, so his average product will be 81 divided by 10, which is 8.1. That is, each of those 10 hours provides him with a product of 8.1 percentage points. Alexi's marginal product is approximately the effect of an additional hour of study on his grade. It is precisely the slope of the production function at any point. Alexi's production function is concave, which implies that Alexi's production function exhibits diminishing marginal product. His marginal product of the 5th hour of study is 7, while his marginal product of the 11th hour of study is 3. Studying a 5th hour increases grade by 7, but the slope of the production function is greater than 7 at 4 hours of study and less than 7 at 5 hours of study. If Alexei further increases his studying to more than 15 hours a day, it has no impact on his grade. Alexei's preferences rank every combination of free time and final grade from best to worst. Alexei always prefers more free time or a higher grade. He prefers A to B, and he also prefers D to C. Alexei is, however, indifferent between points A, E, F, G, H, and D. These points are all points that provide Alexei with the same level of utility. They are on the same indifference curve. An indifference curve gives every combination of final grade and hours of free time that gives the same level of utility, just like the isocost curves from last week. What are some of the properties of indifference curves? Indifference curves slope downward due to trade-off. That means that if Alexei wants a higher grade, he will have to give up some hours of free time per day. Higher indifference curves correspond to higher level of utility. More is better. The further away from the origin that an indifference curve lies, the more preferred are those combinations. Indifference curves are usually smooth. Indifference curves never cross, and as you move right along an indifference curve, its slope gets flatter. This slope of the indifference curve is called the marginal rate of substitution. Let us compare some points along Alexei's indifference curves and find the marginal rates of substitution between his grade and free time. As we said before, Alexei's MRS is how many points he is willing to give up for an additional hour of free time. Alexei's MRS is 9 at point A. That is, if Alexei wants an additional hour of free time, moving from 15 hours of free time to 16 hours of free time, he will have to expect a fall in his grade by 9 points. Alexei's MRS is 4 at point H. So if Alexei wants an additional hour of free time at point H, he will have to give up 4 points. The MRS increases with his final grade. And the MRS also decreases with free time. So, with increasing Alexei's free time, his marginal rate of substitution will be falling. What is your MRS between income and free time? How much income are you willing to give up for an additional hour of free time? This will vary from individual to individual. If you choose your work hours, is your MRS equal to your opportunity cost of an hour of leisure? Alexei's feasible set. Alexei's choice of study hours depends on both his production function and his preferences. If you look closely, you will notice that his feasible set is simply the mirror image of his production function. Given Alexei's production function, point A is what we call feasible, point B is infeasible as it lies outside of his feasible set, and point C is also feasible. Point D, lying inside of his feasible set, is feasible but wasteful. Alexei's optimal choice will be on his feasible frontier. As we saw before, Alexi's marginal product, or his MP, is the slope of his production function. Alexi's MRS, his marginal rate of substitution, is the slope of his indifference curve. The slope of Alexi's feasible frontier is called his marginal rate of transformation. Alexi's marginal rate of transformation is how many points he must give up for an additional hour of free time. Alexi's MRT is 3 at point A because if he wants an additional hour of free time moving from 13 hours a day to 14 hours a day, he will have to give up 3 percentage points. Alexi's MRT at point C is 7. This is because if he wants an additional hour of free time, moving from 19 hours of free time to 20 hours of free time, he must give up 7 percentage points. We see that as free time increases, the MRT increases. And as we saw before, as free time increases, the MRS decreases. Alexi's optimal decision under scarcity. Combining Alexi's indifference curves and his feasible frontier, it allows us to understand his decision making. What feasible combination of grade and free time maximizes Alexi's utility? A and B are both feasible. All points between IC1 and the feasible frontier are better. C is preferred to A and B, so is D. E is Alexi's best choice. Alexi's best choice will be found where the slope of his indifference curve equals the slope of his feasible frontier. That is where the MRS is equal to the MRT. MRS is the marginal rate of substitution, the number of percentage points Alexi is willing to trade for an hour of free time, and the slope of the indifference curve. The MRT, or the opportunity cost of free time, is a number of percentage points Alexi would gain or lose by giving up or taking another hour of free time, and it is the slope of the feasible frontier and equal to the marginal product of labor. Angela's work hours. Alexi's constraint choice problem maximizes utility subject to his feasible frontier. Optimal study hours are chosen. Angela's constraint choice problem is where maximizing utility subject to her feasible frontier occurs, and optimal work hours are also chosen. Today, Angela chooses her work hours independently, but in Unit 5, we will study how her work hours will be determined when she has a landlord. So far, we have met one production function and translated it into a single feasible frontier. But what if something like the Industrial Revolution occurs where there are improvements in technology? How will this impact Angela's production function and work hours and her feasible frontier? PF is Angela's production function before an improvement in technology, and PF new is her production function with the introduction of a new technology. In other words, PF is as a result of economic growth. Economic growth shifts up the production function. We see that with the same number of hours of work per day, with the new production function, Angela can get more output. So when Angela is working 12 hours per day, under the old technology, PF, Angela is only able to get 64 grains. But under the new production function PF new, with the same 12 hours, Angela can get a total of 74 grains produced. This PF can be translated into a feasible frontier where we see that the feasible frontier also shifts upwards. So FF is the old feasible frontier under the old technology, and FF new is a new feasible frontier. We again see that Angela can get more output with the same number of work or the same hours of free time per day. How does Angela choose her work hours? Her work hours are based both on her feasible set and her preferences. Point A represents Angela's preferred point in her feasible set. This is where her MRS equals her MRT. However, Angela's feasible set expands with the adoption of a new plow. With this technology, Angela chooses to produce 6 more units of grain and enjoy 1 more hour of free time. So we see that with improvements in technology, one can produce more and at the same time enjoy more free time. Hours of work and economic growth. In 1930, John Maynard Keynes wrote an essay on the economic possibilities of our grandchildren. That is your generation. He predicted that productivity would continue to rise. He suggested that we could enjoy a 15-hour work week by the 21st century. He argued the economic problem, the struggle of subsistence, would be solved. Then why is it that most Americans still work 40 hours a week and 50 weeks per year?